In the figure on the left, two links are drawn on a grid with a snap to grid option. The links are measured and the two ratios are computed. As the length of either line is changed, the measures and ratios are updated. Creating scale drawings is an application of similarity. Multiplication is a scaling, making something 3 times bigger or 1/2 the size, for example. Scale drawings then are important ways for students to see the connection between multiplicative reasoning and proportional reasoning. On the other figure, page 446 in your book, Activity 17.7, scale drawings would work well with this. But in this drawing, what would you conjecture is the ratio between the areas of the two sailboats? What you need to do is measure and test your hypothesis after you have it. Interesting things to consider for scale drawings. If you want to make a scale model of a solar system, or you can use ping pong balls of the Earth, how far away should they be from the sun? What scale should be used to draw a scale map of the city? Use a scale map on a map to estimate the distance and travel time between 2 points of interest. Roll a toy car down a ramp, timing the trip on a stopwatch. The figure below is based on the ratio of two sides of similar rectangles. After the ratios have been graphed, challenge students to use their graph to determine a 7th look-alike rectangle. Also ask questions to help students understand the graph, such as, what does a point on the graph mean, even if it's not one of the rectangles? What is the length for a look-alike rectangles for the width of 1 centimeter? Activity 17.9. Pose the following problems to students. If you brush your teeth twice a day and leave the water running when you brush, how many gallons of water will you waste in 1 day, 2 days, in a week, or a month, or any number of days? Invite students to gather real data if possible, or use a recommended time to brush teeth for 2 minutes. Ask students to explore the ratio of number of days to waters wasted. In the figure, paper cups of water wasted to gallons of water wasted. Students in our class were challenged to figure out how many paper cups they were used for, meaning would fill a gallon. The class figured out that 2 cups were equal to 1 quart of a gallon. In this example, a student wasted 5 cups of water, reasoned that this would fill 2/5 plus another half of another fourth, or 1/8. So the total is 5/8 of a gallon of water wasted per day. In Activity 17.10, show students a picture of 2 lemonade pitchers, such as the one below. The little squares indicate the recipes used in each pitcher. First one, 3 cups water, 2 cups concentrate, on the right, 4 cups water, 3 cups concentrate. A yellow square is a cup of lemonade with concentrate, and a blue square is water. Ask whether the lemonade in one of the pitchers will be stronger, lemon flavored, or will they taste the same. The recipes can be adapted to indicate fractional values. You could use 3/4 of a cup water, 1/8 cup concentrate, 3/2 water, 1/4 concentrate. The figure below shows 2 different reasoning strategies. When pizzas are sliced up into fractional parts, such as in this figure, approach A, the approach is to look for a unit rate, pizzas per camper. A proportional approach has been used for each ratio, as in division, but notice that this problem does not say that the camps have 3 or 5 campers respectively. Any multiples of 2 to 3 and 3 to 4 can be used to make the approach comparisons. In approach B, 3 clones of 2 to 3 ratios and 2 clones of 3 to 5 ratios are made so that the number of campers get a like number of pizzas can be compared. Ratio tables or charts that show how 2 variables or quantities are related are a good way to organize information. They serve as a tool for applying the building strategy but can be used to determine unit rates. Ratio tables can be used to find specific equivalent ratios. Because different ratios are represented in a ratio table, these ratios can be compared or can be found. We can find the missing value. You may recognize that these tasks are typical self-proportional tasks. One ratio and part of the second are given, with the task being to find the fourth number. The figure to the right shows 3 different ways to use the ratio table to solve the Jupiter's weight task. Tape or strip diagrams are a nice visual that helps students notice multiplicative relationships. They are also known as strip diagrams, bar models, or graphs, or fraction strips, or length models. So here you have the example. The ratio of boys in 2 girls is 3 to 4. So 3 boys to 4 girls. Sorry. Step 1, if there are 12 girls, how many boys? So if you have 12 in total, that's the girls. You have 12 girls, we need to figure out how many boys. In observing the girls' tape, students see that they needed to divide 12 by 4, placing 3 in each portion. Therefore, there is 9 boys. So 3 plus 3 plus 3, or 3 times 3 is 9. There are 21 children. How many are boys? So in the second one, the whole is 21. Second situation is harder for students to solve. In this particular, it can be difficult for students to set up proportions to represent these situations. There are 5 more girls than boys. How many girls are there? So there's 5 more girls than boys. How many girls are there? So it'll be boys plus 5 gives you girls. Setting up proportions or equations and using cross products to find the missing value is sometimes considered the standard algorithm for solving proportions. To build understanding of using proportions, we need to connect students to understanding of equivalent ratios. Rather than starting with telling students to set up a proportion, ask them to illustrate the problem in a way that they show understanding in the figure below. Simply sketch, which then they lead to proportions. And the part B shows a sketch that reflects the context. Both examples include 2 equations, one that focuses on within the ratio, one focuses on between the ratios. When you look at the situation in both these figures, A and B, you can determine the unit rate to solve these problems. As an example, you can find the price of 1 pound of apples by dividing 80 cents by 4 and then multiplying the result by 6 to determine the price of 6 pounds. The equation is 8 tenths divided by 4 times 6 is $1.20, or 1 in 20 hundredths. Or you can examine the scale factor from 4 to 6 within the ratio, which is 1.5, multiplied by 8 tenths, and you get 1 in 2 tenths.